Now, the next piece that we're going to do is going to also help us so we don't have to always be making calls to our Alchemy node here. We don't want to have to run up the bill every single time we run a test suite. We want to be able to do everything locally for as long as possible and not even have to make any API calls to Alchemy. We do want to absolutely test our fork URL, but maybe not all the time. So let's go ahead and clear, let's hide the terminal, and let's keep going. And this is why it's good to have some tests before you even start doing refactoring. This way you can make sure you don't break anything in the process. But all right, great. So how can we update this now? We said before the whole purpose of this refactoring was so that we wouldn't have to hard code an address in here. And sure enough, here we are, we're hard coding an address in here. This still only works with Sepolia. If I try to run this test without a forked chain, it's just gonna fail, right? Because this test price feed version is accurate, needs to make a call to a contract that exists. So what can we do? We can do something called creating a mock contract. On our local Anvil, we can deploy our own fake price feed and interact with that for the duration of our local tests. And that's what we're going to do right now. So to work with these mocks, we're actually going to go ahead and in our script folder, we're going to create a new contract called helperconfig.sol. .s.sol. And in this contract, we're going to do two things. Number one, we're going to deploy mocks when we are on a local Anvil chain. And number two, we're going to keep track of contract addresses across different chains. For example, Sepolia ETH/USD price feed has a different address, or mainnet ETH/USD has a different address. And if we set up this helper config correctly, we'll be able to work with a local chain, no problem, and work with any chain we want, no problem. So let's go ahead and let's do this. So this is a contract. Once again, we're going to need to do the SPDX license identifier MIT. Once again, I'm using GitHub Copilot, which just let me do it by hitting tab. We're going to do pragma solidity 0.8.18. I hit tab again. Thank you, GitHub Copilot. Contract helper config like this. And this helper config is going to be a script, which is why we have this .s.sol to signify it's a script. So to do that, we're going to do import script from forge.std/script.sol like this. And like I said, what this is going to do, we're going to say, if we're on a local Anvil chain, we're going to deploy these mock contracts for us to interact with. Otherwise, let's grab the existing addresses from the live networks. So let's go ahead and create this helper config, which is going to set this up for us so that we don't have to hard code this address in here. And our test will work no matter what we're on, a local chain, a forked chain, or a real chain. So first, let's create a function, and we're going to call it get Sepolia ETH config like this. This is going to be a public pure function. And what this is going to do is it's going to return a configuration for everything we need in Sepolia, or really any chain. All we need in Sepolia is going to be the price feed address. However, we're probably also going to want one for function get Anvil ETH config public pure, which is also just going to need a price feed address. But what if we have a whole bunch of stuff we need? Maybe a price feed address, a VRF address, gas price. What if we've got a ton of stuff in here? Well, this is where it's a good idea to maybe turn this config into its own type. And how do we create types? You got it. That is with the struct keyword. So we're going to create a struct keyword, and we're going to call it network config. So we're going to create a new object of type network config. Right now, our network config is only going to be one thing, address price feed, which is going to be the ETH/USD price feed address. And we're going to have both of these return a network config object with this price feed. So both of these are going to do that. Returns network config, and we have to use the memory keyword because this is a special object. So we're going to do that for both of them. Now for get Sepolia ETH config, it's really easy, right? All we have to do is say network config, Sepolia config equals network config, and we'll just wrap, and we'll just create this object by saying price feed and pasting in the address in here. Network config memory. Since this is a struct, obviously we can use these little brackets here to say the type and the object. We could also just do this, right? We could delete these and just go like this, but I like to be a little bit more explicit. So put these little squiggly brackets, the name of the thing, and then the address. And then we could just say return Sepolia config. And now we have a way to get the Sepolia config. So great. So we have a way to grab an existing address on a live network using this. How do we get that back over here so we can input into the funme? Well, what we can do is we can create a new public variable, network config, public active network config, and we can set this active network config to whichever one of these configs is the active network that we're on. If we're on Sepolia, we'll return this. If we're on Anvil, we'll return whatever is in Anvil, and then we'll have our deploy me just point to whatever the active network config is. So so let's pretend for a second we are on Sepolia. How would we set the active network config? Well, in our constructor, what we'd do is we'd say if block.chainid equals 111551111, I'll explain this in a second, active network config equals get Sepolia ETH config. Now, what is this chain ID thing? Okay, well, first of all, we know that Solidity has a lot of these global variables. One of these is the block.chainid. The chain ID refers to the chain's current ID. We saw a little bit of that with MetaMask and Ganache, and we can see that actually every network has their own chain ID. On this site, chainlist.org, you can see a list of a lot of these different chain IDs. For example, Ethereum mainnet has a chain ID of 1 or 0x1. Binance Smart Chain 56, Arbitrum 46161, Polygon 137, Optimism 10, Avalanche C Chain, blah, blah, blah. They all have different chain IDs. Sepolia has a chain ID of 111551111. So we can just say, hey, if we are on the Sepolia chain, use the Sepolia config. Great. And then we can say if we're not on Sepolia, let's use the Anvil config. Fantastic. So we'll say else active network config equals get Anvil ETH config. Okay, so let's try this out. We don't have our get Anvil ETH config identified yet. We don't have it set up, but that's okay. Let's just make sure that this get Sepolia ETH config works with our forked tests. So let's give that a whirl. So let's update this now to work with our helper config. So we'll do import helper config from /helperconfig.s.sol. And what we're going to do is before the broadcast, we're going to create a new helper config. And GitHub Copilot, thank you again. I just had to hit tab, but helper config, lowercase helper config equals new helper config. So we're going to create a new contract like this. The reason we're going to do this before the start broadcast is we don't actually want to have to spend the gas to deploy this on a real chain. So this is going to be a little bit confusing, but you'll get used to this. Anything before your start broadcast, it's not going to send it as a real transaction. It's going to simulate this in its simulated environment. Anything after start broadcast, it's going to be a real transaction. So we just want to be very certain and very particular with what we put before and what we put after this vm.start broadcast. So now that we have this helper config, we now have access to this active network config, which when we deployed it is going to be updated with the correct helper config here. Now we can get the right address by grabbing it from the helper config. So we can say address ETH USD price feed equals helper config dot active network config price feed. Excuse me, helper config dot active network config. Now, normally, since we're returning a struct, we would have to wrap this in parentheses. And if we had multiple return values in the struct, right? If this was like an address and then another address and then another address, etc., we'd have to do an address and then another address, and then another address, etc. But since it's only one, undo all these as well. But since it's only one, we can wrap it in parentheses like this, and Solidity will just automatically take those away. So this works. So even though active network config is of type network config, this will work correctly. Great. But now we have the ETHUSD price feed. We can stick it in here. So if we're doing this right, if we run forge test --fork URL, Sepolia, RPC URL, we should indeed pass. We should have refactored our code correctly. Fingers crossed. And boom, Okay, our helper config is coming along fantastically. This is great. Let's clear, let's hide this, and let's keep going. So we're able to get this working well. And now this is a strategy we can work with different chains. For example, if we wanted to work with another chain, for example, Ethereum mainnet, we could copy paste this here. We could say get mainnet ETH config, public pure returns network config. We could say ETH config, network config. We could go to docs.chain.link. Let's scroll over to Ethereum. Let's go to ETH mainnet. Where's ETH USD? Let's scroll. ETH USD. We would copy this address here. We'd come back. We'd paste it in here. Copy this, paste it here. And now we would scroll back up. And again, if I'm moving too fast for you, feel free to pause or slow me down. Copy this. We'll come up here. Then we can say else if, and then Copilot's giving me the answer here. But if chain ID equals 1, then active network config equals get mainnet ETH config. So we can use this little else if syntax here to just toggle through all these different chain IDs. And awesome. Now we have a way we could even get the mainnet ETH config. And if we wanted to, what we could do is we go back to Alchemy, create a new app here. We'll call it mainnet. Mainnet Ethereum mainnet. We'll zoom out a little bit so we can click the button. And what we can do is we can grab this key, copy the HTTPS, come back in here. Let's go to our .aave file, create mainnet RPC URL equals this, pull up the terminal, source.env. That way this, if I do echo mainnet RPC URL, I can now see this as an output. What I could do is I could do forge test -- fork URL $mainnet RPC URL. And now I can run my tests even on a forked mainnet. Awesome. And even that passes. So this is a really important step that we want to get really good at is running our tests on a forked mainnet or a forked blockchain that we're actually going to be deploying. So if we wanted to deploy to ETH mainnet, we would do something like this. These days, I don't deploy very much to Ethereum mainnet. I'm usually going to deploy to an L2. So maybe I'll do like a Polygon ZK EVM, Optimism, deploy a lot on Arbitrum, but something like that. And that's where I would do the fork testing against. But in any case, awesome. And the coolest thing about this setup is that if I want to deploy to mainnet, great, it'll just work. Or if I want to deploy to Sepolia, great, it'll just work. And if I want to deploy to any other chain, all I have to do is add an additional network config and we're good to go.